Hi there, welcome to Ancient Cosmos Sleep. Tonight we find yourself drifting along something you never agreed to board, yet have always been riding anyway. A slow, graceful spiral through the galaxy. You might think you're lying still in your room, ceiling fan humming, phone dimming your attention span into soft static, but in reality, your entire solar system is moving like a bead threaded onto an invisible cosmic spiral, sliding through the Milky Way with a kind of patient inevitability. And yes, you probably won't survive this realization in any emotionally stable way if you stare at it too hard. But don't worry, we'll keep the existential dizziness at a comfortable bedtime level. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. If you're watching this from somewhere on Earth right now, drop your location and local time in your mind, or comment it later if you're not already half asleep. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Because what you call night is just your tiny planet rotating while everything else drags you along a far larger motion you never signed a waiver for. Right now, your solar system is not sitting still in space. It is racing, quietly and continuously, through the Milky Way galaxy at hundreds of kilometers per second, tracing a path that is not a perfect circle, not a straight line, but something more like a spiral, stitched into the fabric of motion itself. The mainstream scientific fact here is simple but unsettling. The Sun orbits the center of the Milky Way, completing one full revolution roughly every 225 to 250 million years. That means the last time your solar system was in a similar galactic position, dinosaurs had not yet appeared, and Earth was a radically different place. But here's the quirky detail most people don't think about. That orbit is not clean. It wobbles, it oscillates, it drifts up and down through the galactic plane like a slightly seasick boat riding invisible waves. Some fringe interpretations even describe it as a cosmic corkscrew, though physicists prefer the more boring term vertical oscillation. And of course, historians still argue whether early astronomical models unconsciously hinted at spiral motion through their imperfect star charts, or whether that's just modern imagination retrofitting elegance into ancient confusion. Either way, you are not stationary. You are being carried quietly, constantly, and without any sensation of movement at all. You might notice nothing in your room changes. The walls remain still. Your breathing remains steady. But outside that thin illusion of stillness, the solar system is already deep into its spiral path, pulled forward by gravity, momentum, and the galaxy's enormous rotating structure. And as you drift deeper into this realization, it becomes harder to tell where standing still even means anything anymore. You begin to notice that the spiral you're riding on has a center, a kind of invisible anchor point that your mind instinctively wants to name, even though it's not something you can ever directly see from where you are. Everything in your solar system is quietly falling around that center, like dust caught in a slow whirlpool that stretches across tens of thousands of light years. And you are not on the edge of anything in a dramatic sense. You are simply somewhere along the flow, carried along the same grand orbit as everything else nearby. That center, of course, is the Milky Way's core, where a supermassive black hole called Sagittarius A sits like a silent weight in the middle of a rotating city you can never step outside of. But don't picture it as a cosmic vacuum cleaner sucking everything in. That's Hollywood exaggeration. Instead, It's more like a gravitational metronome guiding orbits without consuming everything around it. The mainstream historical fact here is that astronomers only began to understand the sun's motion through the galaxy in the early 20th century, when figures like Jacobus Kapteyn and later Jan Oort analyzed stellar velocities and realized something unsettling. Nearby stars weren't just random. They were part of a coordinated flow, and the sun itself was moving through that flow like a boat in a river that never stands still. Before that, many models still treated the sun as relatively stationary on a cosmic scale, which now feels almost quaint. You might find it strange that something so enormous was missed for so long, but that's how it often works in astronomy. You don't notice motion when everything around you is moving with you. It takes careful measurement, long observation arcs, and a willingness to trust tiny shifts in starlight over human intuition. The sun travels around the galactic center at roughly 220 kilometers per second. That's not a gentle drift. It's a relentless, high-speed orbit that still feels completely motionless from your perspective on Earth. In 1 second, you've moved farther than entire mountain ranges span. In 1 year, you've traced an arc through space so vast it defies normal imagination, and yet your body insists nothing is happening. There's a quirky detail that makes this even more surreal. The Milky Way itself is not a rigid spinning disk. It has spiral arms that behave more like traffic jams in density waves than solid structures. So as your solar system orbits, it occasionally passes through regions where stars are slightly more crowded, like moving through thicker currents in an ocean you didn't realize you were submerged in. Some fringe astrophysical ideas once suggested that the sun might have a distant companion star, sometimes nicknamed Nemesis, that periodically disturbs the outer solar system and even influences comet showers. While modern surveys have found no solid evidence for such a companion, the idea persists in pop science corners because it feels satisfying. A hidden partner to your cosmic motion, a secret rhythm behind the spiral. Scientists, however, prefer the simpler explanation of gravitational interactions with the galactic disk and passing stars. And yes, historians still argue whether ancient mythologies describing celestial wheels or rotating heavens were intuitive metaphors for real galactic motion, or simply human attempts to make sense of predictable sky patterns without any concept of a galaxy at all. As you ride this orbital path in your imagination, you start to realize the sun is not just moving, it is also slightly bobbing up and down through the galactic plane, like a slow oscillation layered on top of its orbit. This vertical motion takes tens of millions of years to complete one cycle, meaning that long before humans existed, and long after they will be gone, the solar system has been gently weaving a three-dimensional path through the galaxy rather than a flat ring. It's easy to imagine the galaxy as a spinning record, but your journey is more like a needle that refuses to stay on a single groove, constantly lifted and lowered by invisible gravitational textures. And somewhere in that realization, you might feel a subtle shift in how direction itself works. Because there is no true up or down in space like this, only relative motion, only paths shaped by mass and time and distance, folding into each other in ways your brain did not evolve to visualize comfortably. Even the light entering your room right now is part of this larger structure. It left the sun minutes ago, but the sun itself is not where it was yesterday, and neither are you, and neither is anything else in the solar system. Everything is continuously relocating while pretending to be still. You might start to wonder what it even means to be here, if here is constantly sliding along a galactic curve you cannot feel? And yet, despite all of this motion, your nervous system remains stubbornly calm, convinced that stillness is the default state of reality. That contradiction is where the spiral becomes almost poetic. Motion so large, it erases itself from perception. You begin to realize that the spiral you've been drifting along is not just your solar system's personal story. It's part of a much larger structure, a kind of rotating architecture so vast it doesn't feel like movement so much as a slow cosmic habit. The Milky Way itself is not a static backdrop. It is spinning, flexing, and rearranging itself in ways that would look almost alive if you could watch it on a timescale your brain could actually comprehend. But you can't. So instead, your mind stitches it into something softer, a calm, turning spiral, like a galaxy-shaped lullaby you never asked for, but are definitely listening to anyway. The mainstream historical fact here is that the true spiral structure of the Milky Way was only confirmed in the mid-20th century, when radio astronomy allowed scientists to map hydrogen gas clouds through dust that visible light could not penetrate. Before that, astronomers like Harlow Shapley and later Jan Oort contributed to the idea that the galaxy was rotating and structured. But it wasn't until radio observations of the 21-centimeter hydrogen line that the spiral arms became clearly measurable rather than just speculative sketches. That moment quietly changed humanity's map of existence. You went from a star in a vague fog to a traveler inside a rotating spiral system. And yes, that's a slightly uncomfortable upgrade. Now, imagine the Milky Way not as a solid pinwheel, but as something closer to a massive crowd moving through a stadium. The spiral arms are not rigid arms at all. They are density waves, regions where stars bunch up temporarily as they orbit the galactic center. It's a bit like traffic congestion on a cosmic highway, except the cars are stars, the highway is gravity, and nobody is late because nobody is actually going anywhere in a straight line. One quirky detail that tends to surprise people is that if you could zoom out far enough, the Milky Way would not look like a neat spiral drawn with mathematical perfection. It would look slightly messy, asymmetrical, with warped edges and faint tidal streams of stars being pulled from smaller galaxies it has absorbed over billions of years. Some fringe astrophysical interpretations even describe it as a galaxy still digesting its past meals, which is both scientifically poetic and mildly unsettling if you think about it too long before bed. You might also enjoy the idea that there are unofficial galactic calendars some enthusiasts propose, dividing time not by Earth years but by the Sun's orbit around the galaxy, a galactic year. In that system, dinosaurs lived during the same galactic season as we do, just a slightly different position along the spiral track. It's not used in formal astronomy, of course, but it shows how humans instinctively try to scale their sense of time to match the enormous motion they've discovered. Your brain hates being small without context, so it invents cosmic calendars like it's decorating a very large, very dark room. Now here's a gentle joke for you. If you ever feel unproductive, remember that your entire solar system is currently late by about 220 kilometers per second to absolutely nowhere in particular. Another way to say it is, you are always on time, just in a galaxy that refuses to stop moving. And if that doesn't help your anxiety, well, at least it's consistent. The Milky Way's rotation is not uniform either. Inner regions rotate faster than outer regions, a phenomenon known as differential rotation. This means the spiral shape is constantly being stretched and maintained, like dough being slowly twisted by invisible hands. Without this, the spiral arms would wind up too tightly over time, which is one of those cosmic problems that sounds abstract, but is actually fundamental to why galaxies look the way they do. There's another strange implication hidden in this. Nothing in the galaxy shares exactly the same orbital period. Your solar system is always slightly out of sync with its neighbors. Like dancers in a ballroom where everyone is following the same music but stepping at different speeds. You never quite return to the same configuration of nearby stars again, even if the galaxy itself feels cyclical. Historians still argue whether early spiral galaxy sketches from the 18th and 19th centuries were accidental glimpses of truth or simply artistic projections influenced by telescope limitations and human bias towards symmetry. Some drawings eerily resemble modern galactic maps, while others look like decorative seashells in space. The line between observation and imagination has always been thinner than people like to admit. And here is a quieter, stranger thought. Even the spiral arms you imagine are not fixed structures you could stand outside and look at. You are inside them, moving with them, meaning every attempt to visualize the Milky Way is like trying to understand a forest while being a leaf inside it. That's why astronomy often feels like memory rather than sight. You reconstruct what you cannot step outside to see. There is also a subtle psychological trick your brain plays here. Because everything around you appears stable. Your room, your planet, your sky. You instinctively assume stillness is the default condition of existence, but in reality, stillness is rare. Motion is the background. Even galaxies are not resting. They are evolving, colliding, and reshaping over billions of years like slow weather systems in space-time. And you, sitting quietly in your temporary human frame, are part of that weather. Another small joke before we drift further. If galaxies had customer service, the Milky Way would absolutely be on hold with estimated wait time. 4 billion years. And the hold music would just be the faint background noise of hydrogen clouds colliding. You'd still stay on the line, though, because there's nowhere else to go. As you continue to follow the spiral mentally, you might notice something subtle. The more you understand the structure of the galaxy, the less it feels like a place, and the more it feels like a process. A continuous unfolding of motion, where location is just a temporary label assigned to something that is never actually stationary. And somewhere inside that realization, the idea of direction begins to soften. Forward, backward, up, down. All of it becomes relative to a system that is itself rotating while you attempt to define it. You are not looking at the Milky Way. You are participating in it. As you continue drifting through this vast rotating structure, you begin to notice that the solar system's journey is even stranger than a simple orbit around the Milky Way. If the Sun merely traced a flat circle around the galactic center, the story would already be impressive enough for one bedtime. But the universe, as usual, seems incapable of resisting extra complexity. The solar system does not travel neatly within a perfectly flat galactic disk. Instead, it moves slightly above and below the Milky Way's central plane while continuing its enormous orbit. The result is something that resembles a gentle wave layered onto a circle, creating a path that many illustrations simplify into a spiral or corkscrew shape. Imagine walking around a giant circular track while simultaneously riding a slow-moving elevator that rises and falls. Your overall path becomes more complicated than either motion alone. That is essentially what the Sun is doing on a galactic scale. The mainstream historical fact for this part of the story comes from the work of astronomers during the 19th and 20th centuries, who gradually measured the motions of stars and realized that the Milky Way is not a rigid structure. Careful observations revealed that stars drift above and below the galactic plane over immense periods of time, creating vertical oscillations that are now considered a normal part of galactic dynamics. The Sun currently sits only a modest distance above the Milky Way's midplane. Over tens of millions of years, however, it slowly rises and falls through that invisible boundary. One complete up and down cycle takes roughly 60 to 70 million years. To put that into perspective, when the dinosaurs disappeared around 66 million years ago, the solar system was likely in a very different phase of this galactic bobbing motion. You might find it amusing that while humans spend endless effort standing upright, balancing carefully against gravity, the entire solar system is quietly nodding up and down through the galaxy like a sleepy passenger fighting to stay awake during a long train ride. The image becomes even more interesting when you remember that every planet follows the Sun. Earth is not independently weaving through the galaxy. Mars is not choosing its own route. Jupiter is not wandering off to explore. They are all passengers. The Sun acts like the lead runner in an unimaginably large relay race, and the planets are tethered companions following along. Earth circles the Sun, while the Sun circles the galaxy, while the galaxy itself moves through space. Motion layered upon motion layered upon motion. A quirky tidbit sometimes mentioned in popular science discussions involves a controversial hypothesis suggesting that these periodic passages through the galactic plane may correlate with certain events in Earth's geological history. Some researchers have proposed links between plane crossings and increased comet impacts, possibly caused by gravitational disturbances in distant comet reservoirs. The evidence remains debated, and many astronomers remain skeptical of strong claims. Still, it is one of those fascinating ideas that refuses to disappear entirely because it connects deep space motions with events on Earth. Historians still argue whether ancient sky watchers noticed long-term celestial changes significant enough to suspect that the heavens themselves might move in complex ways beyond daily and yearly cycles. Most likely, the timescales involved were simply too enormous to observe directly. Yet many myths describe layered heavens, cosmic rivers, and celestial pathways that sound surprisingly evocative when viewed through a modern lens. Of course, mythology should not be mistaken for astronomy. But it does reveal something important. Humans have always sensed that the sky was more dynamic than it appeared. Now imagine for a moment that you could step outside the galaxy and watch the solar system's motion from afar. You would not see a tidy diagram from a textbook. You would see an astonishing braid of trajectories. Earth loops around the Sun once every year. The Moon loops around Earth roughly every month. The Sun moves around the galactic center. The galaxy itself travels relative to neighboring galaxies. All these motions combine into an intricate three-dimensional dance that no human eye could naturally track. It would resemble a swarm of glowing threads woven together by gravity. A second small joke for the night. If extraterrestrial tourists ever purchase tickets for the solar system motion experience, they may demand refunds because from inside the ride it feels suspiciously stationary. Yet that apparent stillness remains one of nature's most impressive illusions. Your body detects acceleration far more easily than constant velocity. Since the solar system moves smoothly through space, you feel none of it. No cosmic wind presses against your face. No galactic vibration rattles your furniture. The ride remains perfectly silent. In some ways, that silence is more astonishing than the speed itself. Think about it. You are traveling through the galaxy faster than most bullets ever fired on Earth. Yet you can comfortably sip tea, read a book, or struggle to find your missing television remote. The universe allows this contradiction without explanation. Or perhaps the explanation is simply that motion is relative. A person sitting beside you feels stationary. A person on the other side of Earth feels stationary. The entire planet feels stationary. Meanwhile, all of you are moving together through layers upon layers of orbital motion. The concept begins to soften the distinction between movement and rest. They become less like opposites and more like perspectives. Even modern visualizations of the solar system's path can sometimes be misleading. The famous corkscrew animations that circulate online often exaggerate certain aspects of the motion or choose reference frames that make the spiral appear more dramatic. The truth is both subtler and more beautiful. The solar system's path depends on the frame from which you observe it. From one perspective, it looks helical. From another, wavy. From another, almost circular. None are entirely wrong. The universe does not owe us a single simple picture. Instead, it offers multiple viewpoints, each revealing part of the story. And as your imagination follows the sun through its slow rise and fall across the galactic plane, you begin to appreciate that the spiral journey is not merely about speed. It is about layers. Layers of motion, layers of perspective, layers of time. The solar system glides onward through darkness, tracing curves so vast that entire species appear and vanish before one oscillation is complete. Long before humanity arrived, the journey was already underway. Long after humanity is gone, it will continue. The sun will keep weaving its gentle path through the galaxy, carrying its planets like lanterns, drifting through an endless cosmic sea. And somewhere ahead, hidden within that enormous voyage, lies the invisible machinery that creates those paths in the first place. Gravity itself. The deeper you drift into this journey, the more it becomes clear that none of these motions happen by accident. The solar system is not wandering through the galaxy like a leaf blown randomly by the wind. Every curve, every orbit, every slow rise and fall through the Milky Way is shaped by one persistent force quietly operating everywhere at once. Gravity. Not the gravity that makes you drop your phone onto your face when you're falling asleep. That particular lesson in physics has probably happened often enough already. No, this is gravity on a scale so vast that entire star systems spend billions of years obeying its guidance. As you imagine the solar system moving along its immense galactic path, gravity becomes less like a force and more like a landscape. You do not see mountains in space. You do not see valleys, yet they exist in a different sense. Mass creates invisible contours that objects naturally follow, just as rainwater follows the slopes of a hillside. The mainstream historical fact for tonight's stretch of the journey comes from the work of Isaac Newton in the late 17th century. His law of universal gravitation transformed humanity's understanding of the heavens by showing that the same force causing an apple to fall also governs the motion of the moon and planets. For the first time, Earth and sky became parts of a single physical system. That realization was revolutionary. Before Newton, celestial motion often seemed fundamentally different from everyday motion. After Newton, The universe became a place where the same rules applied everywhere. At least, that was the beginning of the story. Centuries later, Albert Einstein refined the picture with his theory of general relativity. According to Einstein, gravity is not simply a force pulling objects together. Instead, mass and energy curve space-time itself, and objects follow those curves. You can picture it as a giant invisible landscape surrounding every star, planet, and galaxy. The Sun creates a deep gravitational valley. Earth follows a path around that valley. The Milky Way creates a vastly larger gravitational structure, and the solar system follows that. One orbit nested inside another, one curve embedded within another. Like Russian dolls made entirely of motion. Here's where things become wonderfully strange. The solar system is not orbiting a solid object at the center of the Milky Way the way a tetherball circles a pole. Instead, it moves through an enormous gravitational environment generated by billions of stars, clouds of gas, dark matter, and the central black hole. The path emerges from the combined influence of all that mass. It is less like circling a single lighthouse and more like navigating an ocean shaped by countless overlapping currents. A quirky tidbit often mentioned in astronomy circles is that Newton himself spent enormous amounts of time studying alchemy and biblical chronology alongside physics. The man who helped explain planetary motion also devoted years to pursuits that modern scientists would consider highly unusual. Genius, it turns out, rarely stays inside neat categories. Historians still argue whether Newton regarded gravity as a complete explanation or whether he believed deeper mechanisms remained hidden beneath it. His private writings suggest a more complicated view than many textbook summaries imply. And perhaps that uncertainty feels appropriate, because gravity remains mysterious even today. Scientists can predict its effects with extraordinary precision. Yet the fundamental nature of gravity continues to inspire debate. Why does space-time curve the way it does? How does gravity connect with quantum physics? Can all fundamental forces eventually be unified? The answers remain elusive. The solar system, meanwhile, seems entirely unconcerned by these philosophical difficulties. It simply keeps moving. If you could see gravity directly, the galaxy might resemble a landscape of enormous hills and valleys stretching across tens of thousands of light years. Stars would flow along invisible contours. Gas clouds would drift through gravitational basins. Entire stellar populations would migrate through structures too large for any single observer to comprehend. The Sun would appear as one traveler among hundreds of billions. A third gentle joke drifts past. Imagine trying to file a complaint with gravity. "Dear Gravity, I would like to remain stationary." Gravity replies, "Request denied. Processing orbital motion." And then the Earth continues spinning, the Moon continues orbiting, the Sun continues circling the galaxy, case closed. As your mind settles into these immense scales, another remarkable feature emerges. Gravity does not merely create motion, it creates stability. Without gravity, planets would fly away into interstellar darkness. Stars would never form, galaxies would disperse. The spiral path of the solar system exists because gravity simultaneously permits movement and prevents chaos. It is a cosmic compromise, freedom constrained by structure, motion guided by geometry. The balance is delicate. Too much velocity and an object escapes. Too little and it falls inward. Somewhere between those extremes lies an orbit. The solar system has occupied that balance for billions of years. And not perfectly, either small gravitational interactions constantly nudge trajectories. Passing stars exert tiny influences. Massive molecular clouds contribute subtle perturbations. Even distant galactic structures leave faint signatures over immense timescales. The result is not a perfectly repeating path, but a living, evolving one. You might imagine a train following rails. The solar system's journey is not like that. It is closer to a boat crossing a vast ocean, while currents slowly reshape the route. Predictable in the short term, complex over the long term, beautiful from every perspective. As you continue riding this invisible pathway through the Milky Way, the concept of a spiral becomes richer than a simple shape. It is no longer merely geometry. It becomes evidence of hidden forces working across unimaginable distances. Every curve reflects gravity's influence. Every orbit records a history of balance. Every trajectory reveals relationships between objects separated by vast gulfs of space. The sun moves because the galaxy shapes its path. The planets move because the sun shapes theirs. Moons move because planets shape theirs. Layer after layer, the universe builds complexity from simple rules. And through all of it, gravity remains patient. It never rushes. It never sleeps. It simply continues sculpting motion across cosmic time. Ahead, that invisible architecture will become even more fascinating. Because before humanity understood galactic orbits and gravitational landscapes, people first had to discover something even more shocking. The Earth itself was moving. As gravity quietly guides the solar system along its immense galactic path, you arrive at a realization that seems obvious now but once shattered humanity's entire understanding of the cosmos. The Earth moves. Not symbolically, not philosophically, actually moves. For most of human history, this idea felt completely wrong. After all, you do not feel the Earth spinning beneath your feet. You do not sense it orbiting the sun. The ground appears steady. The sky appears to move overhead. Every instinct suggests that you are standing still while everything else circles around you. And for thousands of years, many civilizations built their understanding of the universe around exactly that assumption. The mainstream historical fact here is that the heliocentric model, placing the sun rather than Earth near the center of the planetary system, was developed in detail by Nicolaus Copernicus during the 16th century. His work challenged the long-standing geocentric framework that had dominated much of European astronomy. The idea was not entirely new. Ancient thinkers such as Aristarchus of Samos had proposed similar concepts centuries earlier. But Copernicus assembled a mathematical system that made the idea harder to ignore. Even then, acceptance came slowly, very slowly. Humans are remarkably attached to the notion that they occupy the center of things. You can hardly blame them. If you spend your entire life watching the sun rise and set, the idea that Earth is actually moving can feel as convincing as being told your house is secretly riding on the back of a giant migrating turtle, which, to be clear, modern astronomy does not support, at least not currently. One of the fascinating quirks of history is that many early opponents of heliocentrism were not foolish. Some raised reasonable questions based on the observations available at the time. If Earth moved around the sun, why didn't stars visibly shift position? Why didn't people feel motion? Why didn't birds get left behind? These sound amusing today, but they were genuine scientific concerns. The answers required better instruments and deeper understanding. Eventually, observations accumulated. The evidence became overwhelming. The Earth rotates, the Earth orbits the sun, and the sun itself moves through the galaxy. Humanity's perceived place in the cosmos became progressively less central with each discovery. A quirky historical tidbit emerges here. When Copernicus published his major work, De Revolutionibus Orbium Coelestium, it appeared near the end of his life. Legend has it that he received a copy of the printed book shortly before his death. Imagine spending decades reshaping humanity's cosmic map and only barely seeing your work enter the world. History occasionally has a flair for dramatic timing. Historians still argue whether Copernicus viewed his model primarily as physical reality or as a mathematical tool for simplifying planetary calculations. The surviving evidence leaves room for interpretation, and scholars continue debating his intentions. Regardless of motive, the consequences were enormous. Once Earth lost its privileged position, an entirely new perspective became possible. You begin to see why this matters for tonight's spiral journey. Before heliocentrism, the concept of the solar system moving through the galaxy would have been almost impossible to formulate. First, humanity had to learn that Earth moves, then that planets orbit the Sun, then that stars are distant suns, then that the Milky Way is a galaxy, then that galaxies themselves move. Each discovery opened another layer of motion, like peeling an onion made entirely of existential surprises, and unlike a normal onion, this one keeps getting bigger. A second gentle joke drifts by. Every generation thinks it has finally found the universe's center, and the universe keeps politely relocating it somewhere else. The process did not stop with Copernicus. Observations by Galileo Galilei revealed moons orbiting Jupiter, demonstrating that not everything revolves around Earth. Johannes Kepler showed that planetary orbits are elliptical rather than perfectly circular. Later, Newton explained why those orbits exist at all. Piece by piece, the machinery of the heavens became visible. And yet the emotional impact remains surprisingly modern. Even now, if you pause and genuinely picture the Earth racing around the Sun at roughly 30 kilometers per second, it feels strange. Not intellectually strange. Viscerally strange. The room around you feels stationary. Your chair feels stationary. The entire horizon feels stationary. Reality disagrees. You are moving through space at astonishing speed, and that motion is merely one component of an even larger galactic journey. The Sun carries Earth, the galaxy carries the Sun. The larger cosmic structures carry the galaxy. Everything participates, nothing truly stands apart. There is another subtle lesson hidden in this history. Scientific progress often involves replacing comfortable intuitions with less intuitive truths. The Earth feels motionless. It is moving. The Sun appears central. It is one star among hundreds of billions. The galaxy seems permanent. It evolves continuously. Each step away from intuition initially feels unsettling. Then eventually it becomes ordinary. Children today learn heliocentrism in school and rarely think twice about it. An idea that once provoked controversy now fits comfortably into elementary education. Perhaps the same will happen with future discoveries we cannot yet imagine. Maybe one day our current understanding of galactic motion will appear incomplete in ways we cannot presently foresee. Science has a habit of expanding horizons faster than expectations. As your thoughts drift through these centuries of discovery, you can almost feel humanity gradually waking up to larger and larger scales of motion. At first, Earth moved, then the planets moved, then the stars moved, then the galaxy moved. Each revelation widened the stage. Each revelation transformed the meaning of here. And now, riding quietly along with the solar system through the Milky Way, you inherit that long chain of discoveries. You know something that nearly every human who has ever lived did not. You know that your home world is not resting beneath an unchanging sky. It is part of an immense traveling system tracing a graceful path through the galaxy, a path whose details continue to unfold, because even after humanity accepted motion, another challenge remained. If the heavens move, why do the stars seem so fixed? That mystery would occupy astronomers for generations, and its answer would reveal an even deeper layer of the solar system's spiral voyage. The acceptance that Earth moves solved one mystery, but it immediately created another. If the planet races around the Sun, and the Sun races through the galaxy, then why does the night sky appear so stable? Why do the constellations seem to hold their shapes year after year, century after century? You step outside on a clear evening and see familiar patterns scattered across the darkness. The stars seem fixed in place, like tiny nails hammered into a celestial ceiling. Ancient shepherds saw many of the same constellations. Medieval sailors navigated by them. Generations separated by thousands of years looked upward and found reassuring familiarity. Yet the universe you have been exploring tonight is anything but still. The contradiction puzzled astronomers for a very long time. The mainstream historical fact here centers on one of astronomy's most important milestones, the first successful measurement of stellar parallax by Friedrich Bessel in 1838. By observing the star 61 Cygni from opposite sides of Earth's orbit, Bessel detected an extremely tiny positional shift against the background stars. The shift was minuscule, almost absurdly small, yet it proved that Earth truly orbits the Sun and that stars are unimaginably distant. For centuries, critics of heliocentrism had argued that if Earth moved, nearby stars should visibly change position throughout the year. Astronomers searched for these shifts and found nothing. The reason turned out to be wonderfully simple. The stars were much farther away than anyone had imagined. The universe was larger, much larger. You can picture it like standing on a beach and moving a few steps sideways. Nearby objects appear to shift dramatically. Distant mountains barely move at all. The stars are the mountains of the cosmos, except the mountains are separated from you by distances measured in light years. That realization changed everything. The heavens seemed fixed, not because they were stationary, but because they were staggeringly far away. A quirky tidbit from astronomical history involves early attempts to explain stellar stability before parallax was detected. Some observers suggested that the stars might be attached to enormous crystalline spheres surrounding Earth. Others imagined celestial mechanisms so elaborate that they resemble fantasy novels more than scientific models. One medieval cosmological diagram looks less like a map of reality and more like an architect's blueprint for a divine onion, let upon layer upon layer. To be fair, given the limited information available at the time, humanity was doing its best. Historians still argue whether certain ancient cultures suspected that stars were vastly distant suns, or whether such interpretations are modern projections onto older texts. The surviving evidence remains open to debate. Regardless, the discovery of stellar distances transformed the cosmic story. Suddenly, the apparent stillness of the sky became an illusion born from scale. And scale, as you are beginning to notice, is one of the universe's favorite tricks. A gentle joke glides through the darkness. The stars spent thousands of years appearing motionless simply because they were practicing excellent social distancing. Their separation from one another is so immense that even high-speed motion often appears frozen to human observers, yet the stars are moving, every single one. Some travel toward us, some travel away. Some orbit the galactic center faster than the Sun, others move more slowly. The familiar constellations are temporary arrangements, cosmic snapshots caught during a particular moment in galactic history. Take the constellation Orion. Today it appears as a recognizable hunter shape in the sky, but over hundreds of thousands of years, the individual stars will drift into different positions. The pattern will stretch and distort until future observers might not recognize it at all. Constellations are less like permanent structures and more like accidental alignments. Beautiful accidents, admittedly, but accidents nonetheless. As the solar system continues its spiral journey through the Milky Way, the stars around it participate in their own journeys. The galaxy resembles a vast city where every resident follows a unique route through time. No two paths are exactly identical, no configuration lasts forever. Even the nearest stellar neighbors gradually change. Stars that are close today may be distant in the future. New neighbors will arrive, old neighbors will depart. The cosmic neighborhood is surprisingly dynamic for a place that appears so quiet. A second bedtime joke appears briefly before wandering off. If stars maintained social media profiles, their status updates would mostly read, "Currently moving at hundreds of kilometers per second." Feeling stationary. And honestly, that would be accurate. One particularly fascinating consequence of stellar motion involves something called proper motion. Over decades and centuries, careful measurements reveal stars creeping across the sky. Not visibly to the naked eye, not dramatically, but measurably. Astronomers who compare precise observations separated by long periods can literally watch the galaxy rearranging itself. The changes are tiny within a human lifetime, yet they accumulate. Time quietly accomplishes what speed alone cannot reveal. This is one reason astronomy rewards patience. The universe often whispers instead of shouting. You might find yourself imagining what the sky looked like to ancient humans tens of thousands of years ago. The constellations were subtly different. Some stars occupied slightly altered positions. The overall appearance remained familiar, yet not identical. Like meeting an old friend after many years and noticing that something has changed, even if you cannot immediately identify what. The solar system itself contributes to this evolving picture. As the sun moves through the galaxy, your perspective changes, the cosmic scenery slowly shifts, distances change, angles change, relationships change, nothing remains fixed forever. And yet, from your position on Earth, the illusion of permanence remains remarkably convincing. Perhaps that is why humans have historically associated stars with eternity. They seem stable compared to human lives. Stable compared to civilizations, stable compared to recorded history, but compared to galactic timescales, they are travelers too, just slower travelers from your perspective. As you drift deeper into the Milky Way's vast structure, another realization emerges. The stars are not merely distant decorations. They form a community of moving objects sharing the same galactic environment. Some are born together, some pass near one another, some exchange subtle gravitational influences. And all of them contribute, however slightly, to the grand dynamical system carrying your solar system along its spiral path. The night sky is not a static ceiling. It is a crowd in motion, a slow-moving crowd, certainly, but a crowd nonetheless. And thanks to modern instruments, Humanity can now track that movement with extraordinary precision. The fixed stars have revealed themselves as travelers, which naturally leads to the next question. If everything is moving, how do astronomers actually measure the solar system's motion through the galaxy in the first place? That answer requires tools far more precise than anything early sky watchers could have imagined. As the stars gradually surrender their illusion of permanence, you begin to appreciate just how difficult it is to measure motion on a galactic scale. It is one thing to say that the sun moves through the Milky Way. It is another thing entirely to prove it. After all, you are trying to detect the motion of an entire solar system from inside that very solar system. It is a little like trying to determine the exact speed of a ship while locked inside a cabin with no windows. The challenge is enormous, yet modern astronomy has become astonishingly good at solving exactly this sort of problem. The mainstream historical fact for this portion of the journey is the launch of the Hipparcos satellite in 1989, followed decades later by the far more powerful Gaia Observatory. These missions transformed astronomy by measuring the positions, distances, and motions of stars with extraordinary precision. Before such missions, astronomers relied primarily on ground-based observations. Those observations were valuable, but Earth's atmosphere introduces tiny distortions that limit accuracy. Space-based observatories changed the game completely. Suddenly, astronomers could track stellar motions with unprecedented detail. The galaxy began revealing itself not as a static image, but as a living, moving system. Imagine standing atop a mountain and watching an entire city come alive at dawn. At first, everything seems still. Then you notice cars moving, people walking, trains departing, lights changing. The Milky Way underwent a similar transformation. Data turned stillness into motion. One of the remarkable things Gaia has accomplished is creating an extraordinarily detailed map of the galaxy. Instead of measuring a few stars, astronomers can now analyze the motions of billions of them. Billions. That number almost slips past unnoticed because it appears so often in astronomy. But pause for a moment. Each measured star is a distant sun. Each has its own history, its own orbit, its own future, and together they reveal the large-scale flow of the Milky Way. A quirky tidbit from the world of precision astronomy is that some stellar position measurements are so accurate they can detect angular shifts comparable to observing a coin on the moon from Earth. That comparison is often used to help people grasp the extraordinary sensitivity involved. Human eyes could never achieve such precision. Modern instruments, however, thrive on it. Historians still argue whether future generations will view the Gaia mission as a scientific milestone comparable to the invention of the telescope itself. The mission's long-term influence may take decades to fully appreciate. The data continue to reshape our understanding of galactic structure, and that understanding reveals something beautiful. The sun is not simply moving around the galaxy. It belongs to a larger stellar stream. Nearby stars often share related motions because they formed from similar regions or have been influenced by similar gravitational environments. The galaxy contains patterns hidden within patterns. Rivers within rivers, currents within currents, a gentle joke drifts by. If the Milky Way issued traffic reports, they would probably begin with heavy stellar congestion in the Sagittarius Arm. Expect delays of approximately 12 million years. Fortunately, no one seems particularly rushed. Modern astronomers determine the sun's motion using multiple techniques. They measure the positions of stars, They analyze proper motions. They examine radial velocities, the speeds at which stars move toward or away from us. One especially useful tool comes from the Doppler effect. You encounter the Doppler effect all the time on Earth. When an ambulance passes, its siren changes pitch as it approaches and then recedes. Light behaves similarly. When a star moves toward Earth, its light shifts slightly toward shorter wavelengths. When it moves away, the light shifts toward longer wavelengths. These tiny changes allow astronomers to calculate stellar velocities with remarkable precision. The result is a dynamic map of galactic motion, not a photograph, a choreography. And within that choreography, the Sun occupies a specific role. It travels around the galactic center at roughly 220 kilometers per second, though exact estimates vary slightly depending on measurement methods and galactic models. The number itself is impressive. The implications are even more so. Every second of every day, the solar system advances hundreds of kilometers through the Milky Way. You are not revisiting the same place in space tomorrow, or next week, or next year. The cosmic scenery is continuously changing, even if those changes remain invisible on human timescales. A second bedtime joke emerges from the darkness. If you ever felt like your life lacks direction, take comfort in knowing that your solar system has maintained a galactic trajectory for billions of years without consulting a map once. Gravity remains an excellent navigator. The precision of modern measurements has also revealed surprises. Astronomers have discovered evidence of ancient galactic collisions hidden within stellar motions. Certain groups of stars move in ways that suggest they originated in smaller galaxies that merged with the Milky Way long ago. The galaxy carries memories, not written memories, kinematic memories. Patterns of motion preserved across billions of years. Every orbit tells part of a story. Every velocity contains a clue. It is as though the Milky Way keeps a diary written entirely in trajectories, and astronomers have learned how to read it. As you imagine these billions of stars moving through the galactic disk, you begin to appreciate that the spiral journey of the solar system is not isolated. It unfolds within a vast network of interconnected motions. The Sun influences its planets. The galaxy influences the Sun. The galaxy itself bears the marks of interactions with other galaxies. Everything participates in larger systems. Nothing exists entirely alone. This realization has a calming quality. You are not an observer standing outside the universe. You are part of the pattern, part of the flow, part of the motion. The same measurements that reveal the Sun's velocity also reveal a deeper truth. The Milky Way is far more massive than its visible stars alone can explain. Something unseen contributes additional gravity. Something hidden helps shape the paths of stars throughout the galaxy. Astronomers call it dark matter. And as your journey continues, that invisible component will become impossible to ignore, because the solar system's graceful spiral through the Milky Way may owe much of its shape to a substance that no one has ever directly seen. As the measurements become more precise and the map of the Milky Way grows clearer, a peculiar problem begins to emerge. The galaxy does not behave the way it should, or at least, it does not behave the way astronomers initially expected. When scientists calculated the amount of visible matter in the Milky Way, the stars, gas clouds, dust, and everything else they could directly observe, they found that there simply was not enough mass to explain the motions they were measuring. Stars far from the galactic center were moving too quickly, much too quickly. According to the simplest calculations, Those outer stars should have drifted away long ago, yet they remained gravitationally bound. Something unseen was helping hold the galaxy together. And suddenly, your spiral journey acquires an invisible companion. The mainstream historical fact for this part of the story involves the work of Vera Rubin during the 20th century. By studying the rotation of galaxies, Rubin and her colleagues gathered some of the strongest evidence that a large amount of unseen mass exists throughout the universe. The results were surprising. If most of a galaxy's mass were concentrated in its visible stars, orbital speed should decrease significantly farther from the center. Instead, they remained unexpectedly high. The galaxy behaved as though it contained far more matter than telescopes could detect. That missing mass became known as dark matter. It is one of the most important ideas in modern astrophysics, and one of the strangest, because despite decades of research, nobody has directly observed dark matter itself. You see its influence, you measure its effects, you calculate its gravitational fingerprints. Yet its true nature remains elusive. It is a bit like walking through freshly fallen snow and discovering footprints without ever seeing who made them. The evidence is there, the source remains hidden. A quirky tidbit from the history of dark matter is that the first hints appeared long before the concept became widely accepted. In the 1930s, Fritz Zwicky noticed that galaxies within clusters were moving too rapidly to be held together by visible matter alone. His conclusions were largely ignored for years, partly because the evidence was incomplete, partly because Zwicky himself had a reputation for being, shall we say, exceptionally direct with colleagues. Scientific history occasionally reminds you that being correct and being persuasive are not always the same thing. Historians still argue whether dark matter will ultimately prove to be a new type of particle or whether it reflects a deeper modification of our understanding of gravity itself. The debate continues. Most evidence currently supports the dark matter explanation, but the door remains open to future surprises. And astronomy has never been shy about surprises. As you continue following the solar system's path through the Milky Way, dark matter begins to take on a more tangible role. The visible galaxy, the stars and glowing gas, is only part of the structure. Surrounding it is an enormous dark matter halo extending far beyond what telescopes can directly image. Imagine a luminous city floating inside a vast invisible landscape. The lights reveal where people live. But most of the territory remains unseen. The Milky Way appears to exist inside such a hidden framework. The solar system, therefore, travels not merely through a galaxy of stars, but through a much larger gravitational environment dominated by something mysterious. A gentle bedtime joke drifts past. Dark matter has managed to become one of the most influential components of the universe, while maintaining perhaps the greatest commitment to privacy in cosmic history. No interviews, no photographs, just gravity, yet gravity is enough. Without dark matter, the spiral structure of galaxies would be difficult to explain in its current form. Without dark matter, galactic evolution would likely look very different. Without dark matter, the solar system's long journey through the Milky Way might not resemble the graceful orbit you have been imagining tonight. The invisible shapes the visible. That lesson appears repeatedly throughout astronomy. You do not see gravity, you see what gravity does. You do not see space-time, you see how objects move within it. And you do not see dark matter. You see its fingerprints across the cosmos. As your thoughts wander deeper into the galactic halo, You might picture vast regions surrounding the Milky Way where stars become sparse and darkness dominates. Even there, gravity remains active. Dark matter continues exerting influence. The galaxy extends beyond its shining disk in ways that challenge everyday intuition. Another fascinating consequence emerges. The Milky Way itself is not moving through empty space. It exists within larger structures shaped partly by dark matter. Galaxy groups, galaxy clusters, immense cosmic filaments stretching across hundreds of millions of light years. The spiral journey of the solar system unfolds within nested structures that grow progressively larger. Each scale introduces new gravitational influences. Each scale reveals additional layers of cosmic organization. The universe resembles a set of Russian dolls made of gravity and time. Open one layer and another appears, then another, and somewhere beyond the scales you can easily imagine lies a complexity that human minds struggle to visualize completely. A second gentle joke arrives before slowly fading away. If dark matter ever decides to reveal itself, astronomers may collectively respond with the scientific equivalent of, well, that would have been useful information earlier. Until then, the mystery remains. Yet there is something soothing about that. Not every question has been answered. Not every map is complete. The universe still contains genuine unknowns. And despite all our instruments, equations, and observations, we remain explorers. Tonight's spiral journey is therefore not merely a tour of what humanity knows. It is also a reminder of what humanity does not know. The solar system glides onward through a galaxy partly shaped by an invisible substance. Stars continue orbiting. Dark matter continues exerting influence, and astronomers continue searching. Meanwhile, another set of influences quietly affects the solar system's path. Not dramatic influences, not galaxy-defining influences, but subtle gravitational nudges from nearby stars, gas clouds, and neighbors sharing the same region of the Milky Way. Because even during a billion-year journey, companions occasionally pass close enough to leave their mark. As the solar system continues its patient voyage through the Milky Way, dark matter may provide the grand stage, but the local cast of characters also matters. You are not traveling through an empty galaxy. Far from it. The sun moves through a neighborhood populated by stars, stellar remnants, gas clouds, dust, and occasionally some remarkably strange cosmic objects. Most are separated by enormous distances, yet over millions of years even distant neighbors can exert subtle influences. Think of the solar system as a small boat crossing an immense ocean. The overall current may determine the general direction, but local waves, shifting winds and nearby vessels can still alter the details of the journey. The mainstream historical fact for this section involves the discovery and study of nearby stars such as Proxima Centauri, whose distance was gradually refined through increasingly precise astronomical measurements. Understanding the Sun's stellar neighborhood became one of the key achievements of modern astronomy, revealing that our solar system resides within a dynamic local environment rather than cosmic isolation. Today, the nearest known star system lies a little over 4 light-years away. That sounds close by galactic standards. In everyday terms, it is hilariously far away. If the Sun were the size of a grapefruit, the nearest star would still be hundreds of kilometers distant. Space takes personal boundaries very seriously, yet over millions and billions of years stars drift. The Sun encounters new neighbors, old neighbors move away, the local stellar population changes. The galaxy quietly rearranges the furniture, A quirky tidbit often discussed among astronomers concerns a star known as Schultz's star. About 70,000 years ago, this faint star passed relatively close to the solar system. Not close enough to threaten Earth, thankfully, but close enough to travel through the outer regions associated with the distant comet reservoir known as the Oort cloud. Imagine a neighboring star briefly passing through your cosmic backyard, not knocking on the door, not borrowing sugar, just casually strolling through the outer edge of the property. Galactic neighborhoods are strange places. Historians still argue whether ancient observations of unusual comets inspired stories that indirectly reflected long-term celestial disturbances, or whether such connections are purely coincidental. The evidence remains uncertain, but the debate occasionally resurfaces whenever discussions turn toward humanity's relationship with the changing sky. The Oort cloud itself deserves a moment of attention. It is a hypothetical but strongly supported spherical reservoir of icy objects surrounding the solar system at tremendous distances. Most of its members are too small and too distant to observe directly, yet their existence helps explain the origin of many long-period comets. You can picture the Oort cloud as a faint shell of frozen debris enveloping the solar system, a distant frontier, a sleepy population of icy wanderers. And occasionally, passing stars disturb that population, tiny gravitational nudges accumulate, some objects are redirected, some begin long journeys inward. Eventually, a few become visible comets crossing the inner solar system. The butterfly effect, cosmic addition, a gentle bedtime joke drifts by. Somewhere in the Oort cloud, a comet may be spending millions of years preparing for a brief appearance before immediately disappearing again. The ultimate example of spending centuries getting ready for a 5-minute presentation. Yet even these small gravitational encounters reveal something important. The solar system is not sealed off from the rest of the galaxy. Its environment matters. Nearby stars matter. Massive molecular clouds matter. The local gravitational landscape matters. Every encounter leaves traces, not dramatic traces most of the time, subtle traces. The kind that become noticeable only when viewed across immense stretches of time. Astronomers have identified evidence that the Sun currently resides within a region called the local bubble, a relatively low-density cavity in the interstellar medium likely created by ancient supernova explosions millions of years ago. Think about that for a moment. The solar system is traveling through the aftermath of stellar explosions that occurred long before humans existed, not directly through the explosions themselves. Through their lingering influence, the galaxy remembers. A second gentle joke appears briefly. Cosmic real estate advertisements would probably describe the local bubble as quiet neighborhood, low gas density, excellent views, occasional supernova history. The property values remain difficult to estimate. As the Sun continues orbiting the Milky Way, it also passes through spiral arms and inter-arm regions. These environments differ slightly in stellar density and gas content. Some regions contain more star formation, others are comparatively sparse. The journey resembles traveling through different districts of a vast galactic city. Each district has its own character, its own history, its own gravitational texture. And because the galaxy evolves, those districts evolve as well. Nothing remains fixed. Even the Milky Way's spiral structure shifts gradually over time. This means the solar system's future route will not simply retrace its past. The galaxy itself changes while the journey unfolds. One particularly fascinating possibility involves close stellar encounters in the distant future. Simulations suggest that nearby stars may occasionally pass near enough to influence the outer solar system, not catastrophically, usually not even noticeably on human scales, but enough to alter the trajectories of distant icy bodies, enough to remind you that gravity extends its reach far beyond the planets. The Sun may dominate the solar system, but it does not completely isolate it. The Milky Way remains present, always present. Its gravitational influence permeates everything, and perhaps that is one of the most calming aspects of this story. Nothing travels entirely alone. The solar system participates in a network of relationships stretching across light years. Stars influence stars, clouds influence stars, galaxies influence galaxies. The universe functions less like a collection of isolated objects and more like an interconnected web of motion. As you continue imagining the Sun carrying its planets through this changing neighborhood, the spiral journey begins to feel less mechanical and more communal. Not alive in the biological sense, but connected, responsive, interwoven. The path of the solar system emerges not from a single cause, but from countless influences operating together. And humanity, naturally, has long tried to explain such patterns using stories. Long before modern astronomy measured stellar velocities or mapped dark matter halos, people looked at spirals in nature and imagined deeper meanings. Those myths and interpretations would become some of the earliest attempts to understand the cosmic motions we now study scientifically. As the solar system glides through its changing stellar neighborhood, you begin to notice something curious about the human mind. Whenever people encounter a spiral, they rarely leave it alone. They see spirals in seashells, spirals in hurricanes, spirals in vines climbing towards sunlight, spirals in fingerprints, spirals in galaxies, and almost immediately they begin assigning meaning to them. Perhaps that is because spirals feel different from other shapes. A straight line suggests a beginning and an end. A circle suggests endless repetition. But a spiral seems to promise both movement and continuity at the same time. You keep returning, yet you never return to exactly the same place. It is not surprising that many cultures found something profound in that idea. The mainstream historical fact for this section is that numerous ancient civilizations incorporated spiral motifs into their art, architecture, and cosmological symbolism. From Neolithic carvings at Newgrange to decorative motifs in Greek, Celtic, Mesoamerican, and East Asian traditions, spirals repeatedly appeared long before anyone knew galaxies existed. The people creating those symbols were not describing the Milky Way's structure in a scientific sense, at least, as far as evidence indicates, yet the recurrence of spiral imagery remains striking. You can almost imagine ancient observers staring into whirlpools, storms, and curling plants, sensing that nature preferred certain patterns. And in many ways, nature does. A quirky tidbit comes from various ancient traditions that imagined the heavens as rotating layers, wheels, or cosmic rivers. Some mythological systems described celestial realms turning around a central axis, carrying stars and planets through the sky. Modern readers occasionally point to these stories and claim they somehow anticipated galaxies. That interpretation is usually a stretch, a very enthusiastic stretch. The kind of stretch that would make a yoga instructor slightly concerned. Still, the symbolism reveals something interesting. Humans sensed motion long before they understood its mechanisms. Historians still argue whether recurring spiral motifs across distant cultures emerged independently from observing natural patterns, or whether deeper symbolic meanings spread through ancient cultural exchanges. The debate remains lively, and perhaps appropriately so. Spirals themselves seem resistant to simple explanations. As astronomy developed, scientific understanding gradually replaced mythological descriptions of celestial motion. The heavens ceased to be rotating crystal spheres. They ceased to be divine wheels. They ceased to be cosmic machinery built solely for human observation. Instead, they became physical systems governed by natural laws, yet the fascination with spirals survived. In fact, it grew stronger. When astronomers eventually discovered spiral galaxies, many people felt an immediate sense of recognition. The shape seemed familiar, not because humanity had secretly known about galaxies all along, but because spirals already occupied a special place in human imagination. A gentle bedtime joke drifts by. If the universe ever had a favorite geometric shape, spirals would probably suspect they were winning the popularity contest. And they might have a point. You encounter spirals throughout the cosmos. Young stars form within rotating clouds. Accretion disks swirl around black holes. Galaxies display spiral structures. Even large-scale weather systems on planets frequently exhibit spiral patterns. The shape emerges naturally whenever rotation and flow interact. That does not make spirals mystical. It makes them effective. Consins often favors patterns that efficiently distribute motion and energy. Spirals happen to be one of those patterns, yet mythology and science approach the shape differently. Mythology asks what a spiral means. Science asks how it forms. Neither question is inherently wrong. They simply serve different purposes. One seeks symbolism, the other seeks mechanisms. And tonight, as you follow the solar system's spiral-like path through the galaxy, both perspectives can coexist comfortably. You can appreciate the physics without abandoning the wonder. A second gentle joke appears. Somewhere, a spiral seashell is probably very pleased to discover it shares a visual theme with entire galaxies. Cosmic branding is apparently quite consistent. Modern astronomy reveals that the solar system's motion is not a perfect spiral in any universal sense. The exact appearance depends heavily on your chosen frame of reference. Change the viewpoint and the shape changes. This often surprises people. Many popular illustrations show the solar system tracing a beautiful corkscrew through space. Those images capture part of the truth, but only part. Coincidence cares deeply about reference frames. A path that appears spiral from one perspective may appear wavy, looping, or nearly circular from another. The universe does not privilege a single viewpoint. That lesson alone has profound implications. Reality often depends on how you choose to describe it, not because truth is subjective, but because perspective matters. Astronomy repeatedly teaches this. Earth seemed stationary until viewed differently. The stars seemed fixed until measured carefully. The galaxy seemed static until mapped precisely. Every advance required a shift in perspective, and perhaps myths performed a similar function in their own way. They provided frameworks through which people could interpret experiences that exceeded ordinary understanding. The frameworks were not scientifically accurate, yet they helped humans engage with mysteries that would otherwise feel overwhelming. As your imagination drifts through the Milky Way tonight, you inherit both traditions. The scientific tradition gives you measurements, equations, and models. The mythological tradition gives you metaphors, stories, and symbols. Together, they enrich the journey. The solar system remains a physical system governed by gravity. Its motion remains measurable, its orbit remains calculable. Yet none of that diminishes the quiet beauty of imagining yourself carried along a vast galactic spiral beneath an ocean of stars. In fact, understanding often deepens wonder rather than reducing it. The more accurately you understand the universe, the stranger it becomes. And sometimes the strangest ideas inspire even stranger theories. Because whenever a fascinating concept enters popular imagination, unconventional interpretations inevitably follow. The spiral motion of the solar system is no exception. Over the years, it has attracted an assortment of fringe theories, speculative ideas, and imaginative cosmic proposals that stretch far beyond mainstream astrophysics. Some are intriguing, some are peculiar, and some wander so far from established science that they practically require their own galaxy. As the spiral shape settles into the imagination, it begins doing what fascinating ideas often do. It attracts company. Not all of that company comes from mainstream science. Some arrives from speculation, some from philosophy, some from enthusiastic internet diagrams created at 2 in the morning by people who started researching galactic motion and somehow ended up explaining the destiny of consciousness. The solar system's spiral journey has inspired an astonishing variety of unconventional interpretations over the years. Most are not supported by evidence. Some contain kernels of legitimate scientific ideas wrapped inside imaginative conclusions, and a few are so creative that you almost want them to be true, simply because they would make the universe even stranger than it already is. The mainstream historical fact for this section is that astronomy has repeatedly advanced by testing unusual hypotheses against observation. Throughout history, scientists proposed competing explanations for celestial phenomena, and evidence gradually separated useful ideas from inaccurate ones. That process remains central to science today. A hypothesis is not accepted because it sounds exciting. It is accepted because observations support it. That distinction is important because spirals have a remarkable ability to inspire grand claims. One quirky fringe idea suggests that spiral motion itself possesses special cosmic significance, as though the universe intentionally favors spirals as a fundamental organizing principle beyond ordinary physics. In these interpretations, everything from galaxies to human thought patterns becomes evidence of a hidden spiral architecture guiding reality. The difficulty is that while spirals certainly appear throughout nature, their presence often emerges naturally from known physical processes. You do not need a mysterious cosmic spiral force to explain hurricanes, seashells, or galaxies. Rotation and flow already do a remarkably good job. Still, the appeal remains understandable. Humans love recurring patterns. When the same shape appears across many scales, it feels meaningful. Sometimes it is meaningful, sometimes it is simply mathematics doing what mathematics does. Historians still argue whether certain early cosmological philosophies should be viewed as proto-scientific attempts to understand nature or primarily symbolic systems concerned with spiritual meaning rather than physical explanation. The boundary is not always clear. Many ancient thinkers blended observation, philosophy, and mythology into frameworks that modern categories separate more sharply. Another fringe proposal occasionally discussed involves the idea that the solar system's passage through different regions of the galaxy directly governs major cycles in human civilization. Versions of this theory vary widely. Some suggest links to climate. Others suggest effects on consciousness. Still others propose periodic cosmic influences shaping historical events. The evidence supporting such claims remains weak. Human history is extraordinarily complex. Galactic motion operates on timescales vastly longer than most civilizations. Yet the notion persists because it offers a compelling narrative, a grand cosmic clock influencing human affairs. You can see why people find that attractive. A gentle bedtime joke arrives quietly. If the Milky Way were actually controlling civilization according to a strict schedule, it has demonstrated a truly impressive commitment to paperwork. The timelines involved are immense. Millions of years. Tens of millions of years, far beyond the lifespan of any empire. Then there are speculative ideas concerning consciousness and motion. Some fringe writers have proposed that humanity experiences reality differently because the solar system moves through particular regions of space. Others imagine hidden cosmic energies flowing along galactic spirals. To date, no reliable evidence supports these claims. Modern neuroscience and physics provide more grounded explanations for perception and cognition. Still, these theories reveal something interesting about human psychology. People often seek connections between personal experience and larger cosmic structures. The desire itself is understandable. You live inside the universe. It feels natural to wonder whether the universe influences you in ways not yet understood. A second quirky tidbit comes from recurring claims that ancient civilizations somehow possessed advanced knowledge of galactic structure. Certain spiral symbols are occasionally cited as evidence. The problem is that spirals are common patterns in nature. Finding a spiral carved into stone does not automatically imply knowledge of spiral galaxies. Otherwise, every snail would qualify as an astronomer, which, admittedly, would make scientific conferences much slower. A second gentle joke slips past and continues on its way. Mainstream astronomy remains remarkably successful because it continuously tests ideas against observation. The solar system's motion can be measured. The galaxy's rotation can be measured. The effects of gravity can be measured. Predictions can be checked. Results can be repeated. That process does not eliminate mystery. Far from it. It simply helps distinguish between questions that remain open and answers that have already been tested. And there are still plenty of open questions. Dark matter remains mysterious. Dark energy remains mysterious. The ultimate fate of the universe remains under investigation. The relationship between gravity and quantum mechanics remains unresolved. Science has not reached the end of discovery. Not even close. In fact, some of today's accepted theories might one day be revised by deeper insights. That possibility is not a weakness. It is one of science's greatest strengths. Knowledge evolves, souls improve, understanding grows. The universe keeps offering new puzzles. As you continue following the solar system through the Milky Way, the distinction between mainstream science and speculation becomes clearer. Science provides increasingly detailed maps. Speculation explores possibilities beyond those maps. Sometimes speculation inspires useful ideas. Sometimes it wanders into territory unsupported by evidence. The challenge is learning the difference. And perhaps that challenge never fully disappears. Every generation inherits mysteries. Every generation proposes explanations. Every generation must decide which ideas survive careful scrutiny. Meanwhile, the solar system itself continues moving regardless of human theories. It does not pause for debates. It does not adjust its orbit to accommodate philosophical preferences. It simply follows the gravitational structure of the galaxy. Quietly, consistently, there is something comforting about that. Reality continues even while humans argue about its interpretation. The stars continue moving, the galaxy continues rotating, the spiral journey continues unfolding. And somewhere within that journey lies another profound consequence of motion. Because movement through space is not entirely separate from time. In modern physics, space and time are deeply connected. The path your solar system follows through the galaxy is not merely a route through space. It is also a journey through time itself. As the solar system continues its immense journey through the Milky Way, you begin to encounter a realization that would have seemed almost magical to earlier generations. Space and time are not separate stages on which events unfold. They are woven together. The path of the solar system through the galaxy is not merely a movement from one location to another. It is a trajectory through space-time, a combined fabric in which distance and duration are deeply linked. This idea is one of the most extraordinary achievements of modern physics. Unfortunately for bedtime purposes, it is also one of the most wonderfully mind-bending. The mainstream historical fact here is the publication of the Albert Einstein theory of special relativity in 1905, followed by general relativity in 1915. These theories transformed humanity's understanding of motion, gravity, and time itself. Before Einstein, time was often imagined as a universal clock, ticking identically everywhere. After Einstein, that comforting simplicity disappeared. Time became flexible, not arbitrary, not imaginary. Flexible, its passage depends on motion and gravity. Now, before your sleepy brain decides to submit a formal complaint, don't worry. You do not need advanced mathematics to appreciate the basic idea. Imagine two clocks. One remains stationary relative to you. The other moves at extremely high speed. According to relativity, the moving clock experiences time slightly differently. The effect is tiny at ordinary speeds, but it becomes significant as velocities approach the speed of light. The solar system's galactic motion is nowhere near light speed, so these effects remain extremely small in everyday terms. Yet the principle remains profound. Motion and time are connected. The universe does not treat them as separate categories. A quirky tidbit that often surprises people is that relativity is not merely a theoretical curiosity. Systems such as the global positioning system rely on relativistic corrections to maintain accuracy. Without accounting for time dilation, GPS errors would accumulate rapidly. In other words, modern navigation works partly because Einstein was annoyingly correct. The satellites agree. Kings agrees. And your phone quietly benefits from it every day. Historians still argue whether Einstein himself fully appreciated how dramatically the public would interpret relativity, often extending its philosophical implications far beyond the original scientific framework. The theory quickly became a cultural phenomenon, as well as a scientific one. People sensed that something fundamental had changed. And they were right. As you imagine the solar system tracing its path around the Milky Way, you can begin thinking of that motion in a slightly different way, not merely as movement through space, but as a continuous journey through space-time. Every second that passes carries you forward in time. Every second also accompanies motion through the galaxy. You cannot separate the two. You are always doing both. A gentle bedtime joke drifts by. Despite all the mysteries of relativity, one fact remains universally accepted. Time moves fastest when you're on vacation and slowest when waiting for software updates. Hiskings has yet to publish a formal equation for this phenomenon, at least not publicly. One fascinating consequence of Earth's motion is that no human has ever occupied precisely the same location in space-time twice. You may revisit a room, you may revisit a city, you may revisit a memory, but the Earth has moved, the Sun has moved, the galaxy has moved. The coordinates are never identical. Every moment is genuinely unique. This gives a different flavor to the solar system's spiral journey. The path is not a loop that endlessly repeats. It is an unfolding sequence, a progression, a river rather than a circle. Even if certain motions appear cyclical, the larger context continues evolving. The galaxy changes, stars change, distances change, time itself advances. And because the solar system participates in all these processes simultaneously, its journey becomes richer than a simple orbit. A second quirky tidbit emerges from cosmology. Some researchers have explored whether large-scale motions through the universe could leave subtle signatures in the cosmic microwave background. The ancient radiation left over from the early universe. These measurements help astronomers understand how galaxies, including the Milky Way, move relative to the broader cosmos. The details are complex. The implication is simple. Even our galaxy participates in larger motions. The nesting continues. Planet within solar system within galaxy, galaxy within larger cosmic structures. Each level contributes its own trajectory. Each level contributes its own story. A second gentle joke appears before floating away. If space-time had a customer support department, every question would probably receive the same response. Your location depends on your frame of reference. Not particularly satisfying, technically accurate, classic physics. As your imagination follows the sun through the Milky Way tonight, you might notice a subtle emotional shift. The immense scales that once felt overwhelming begin to feel calming. The motion remains vast. The distances remain enormous. Yet the pattern becomes familiar. You are not lost in the cosmos. You are participating in it. Every heartbeat occurs within this larger journey. Every breath accompanies the motion. Every human life unfolds aboard a planet, traveling through a galaxy that itself travels through an evolving universe. There is something surprisingly comforting about that perspective. You do not need to steer the galaxy. You do not need to manage the orbit. You do not need to supervise gravity. The universe has been running this particular system for billions of years without requiring your intervention, which is fortunate because most of us struggle to keep houseplants alive. The solar system continues onward. Time continues onward. The journey unfolds whether anyone notices or not. And ahead lies perhaps the most fascinating question of all. Where is this path leading? If the solar system keeps moving through the galaxy for millions and billions of years, what future awaits this quiet, spiral voyage? That future stretches farther than imagination comfortably reaches. Yet tonight, you can follow it a little farther into the darkness. As the solar system continues gliding through the Milky Way, you find yourself looking ahead rather than behind. The past has carried you through spiral arms, stellar neighborhoods, gravitational landscapes, and billions of years of galactic motion. Now the question becomes wonderfully simple. What happens next? The answer, naturally, unfolds on timescales so enormous that human history barely registers as a footnote. If humanity's entire recorded history were compressed into a single second, the future journey of the solar system would still stretch far beyond the horizon of imagination. Yet gravity already knows the route, not every detail, not every encounter. But the broad outline is surprisingly clear. The mainstream historical fact for this section is that modern astrophysicists use sophisticated computer simulations to model the future evolution of the Milky Way and the solar system's place within it. These simulations combine observations, gravitational theory, and stellar dynamics to project how galactic structures may evolve over billions of years. The results reveal a future both familiar and astonishing. For the foreseeable future, the Sun will continue orbiting the Milky Way, the planets will continue orbiting the Sun, the galaxy will continue rotating, the great cosmic machinery will keep turning. You might imagine that after billions of years the solar system would somehow reach a destination, a final point, a cosmic finish line. But that is not how orbital motion works. The journey itself is the destination. The solar system is not traveling toward a place. It is participating in an ongoing process, a very large process, a very patient process. A quirky tidbit emerges from long-term simulations of stellar motion. Over hundreds of millions of years, many of the stars currently visible in Earth's night sky will be replaced by entirely different configurations. Future skies will look unfamiliar, constellations will distort, new stellar patterns will emerge. Ancient navigators would not recognize them, neither would you. The galaxy quietly redesigns its own ceiling. Historians still argue whether future civilizations, if they exist, will preserve records of today's constellations as cultural artifacts long after the actual star patterns have changed beyond recognition. It is an intriguing thought. People may someday study Orion the way modern humans study ancient maps, not because the sky still looks that way, but because it once did. The future of the solar system itself contains another profound milestone. In approximately 5 billion years, the Sun will exhaust the hydrogen fuel in its core and begin transforming into a red giant star. This is one of the most firmly established predictions in stellar astrophysics. The process will unfold gradually. The Sun will expand enormously. The inner solar system will change dramatically. Earth's long-term prospects during this phase are, to put it politely, not especially encouraging. Fortunately, you have plenty of time to reorganize your schedule. 5 billion years should provide a reasonable planning window. A gentle bedtime joke drifts past. Somewhere in the distant future, a cosmic calendar reminder may appear reading, Sun becoming red giant today. Most users will probably still click Remind me later. Yet even that transformation does not end the solar system's galactic journey. The Sun's outer layers will eventually drift away. Its core will remain behind as a white dwarf. The surviving remnants of the solar system will continue orbiting the Milky Way. The spiral voyage goes on, changed, but not stopped, and the galaxy itself faces an even larger future event. Astronomers predict that the Milky Way and the nearby Andromeda galaxy will eventually collide and merge not tomorrow, not next century, roughly 4 to 5 billion years from now. The word collision sounds violent. In reality, most stars are so widely separated that direct impacts remain unlikely. Instead, the galaxies will pass through one another, their gravitational fields reshaping both structures over vast spans of time. The result will be a new galaxy. Larger, different, transformed. The solar system, if it still exists in recognizable form, will participate in that merger. Imagine that for a moment. You are currently traveling through a galaxy that is itself heading toward a future encounter with another galaxy. Even the Milky Way's journey has a journey. The nesting never quite ends. A second quirky tidbit involves simulations suggesting that the solar system could eventually occupy a different region of the merged galaxy than it does today. Its orbital path may be altered. Its stellar neighborhood may change. Future skies could become spectacularly unfamiliar. The universe remains creatively unpredictable. A second gentle joke wanders through the darkness. Moving houses is stressful enough on Earth. The Milky Way has apparently decided to relocate using an entire galaxy merger. Ambitious planning, as you imagine these immense futures unfolding, something interesting happens. The scales become so large that fear begins to fade. 5 billion years, 10 billion years, hundreds of millions of years, the numbers exceed ordinary emotional intuition. They become almost geological, almost musical, long rhythms unfolding across cosmic time, and within those rhythms, the solar system continues tracing its path, orbit after orbit, cycle after cycle. Never exactly repeating, never entirely ending. The future remains open. There will be stellar encounters, galactic evolution, structural changes, unexpected discoveries, perhaps even phenomena that current science has not yet imagined. The universe has repeatedly surprised humanity. There is little reason to believe it has finished. Yet through all those future transformations, one theme remains constant. Motion, the same motion that carried the solar system through the galaxy long before humans appeared. The same motion carrying it tonight. The same motion that will continue long after today's civilizations become distant memories. The spiral journey is not merely a feature of the cosmos. It is one expression of a deeper truth. The universe is dynamic. Everything changes, everything moves, everything participates in larger patterns. And as you approach the final stretch of tonight's voyage, those patterns begin to soften into something quieter, not a calculation, not a prediction, a perspective. A chance to simply rest within the realization that you are part of a cosmic journey already billions of years old. As the future stretches away into distances so immense that even galaxies begin to feel temporary, you find yourself returning to the present moment. Not because the journey is ending. It is not. The solar system continues its motion through the Milky Way exactly as it did before you started listening tonight. The sun still carries its family of planets. The galaxy still turns. The stars still drift. Gravity still patiently sculpts invisible pathways through space-time. Nothing has stopped. Only your perspective has changed. And perhaps that is the quiet gift hidden within this spiral voyage. You began in a room that felt still. Now you know that stillness is in many ways a beautiful illusion. You are sitting on a planet orbiting a star. That star is orbiting the center of a galaxy. That galaxy moves among countless others, and all of it unfolds within a universe far larger than any civilization has ever fully understood. Yet somehow, despite all that motion, you remain capable of experiencing calm. That may be one of the strangest facts of all. The mainstream historical fact for this final reflection is that modern astronomy has revealed humanity occupies no central location in the cosmos. Over centuries, observations gradually displaced Earth from the center of the solar system, then the Sun from the center of the galaxy, and eventually the Milky Way from any privileged position in the universe. Each discovery could have felt diminishing. Instead, many people find it liberating. You do not need to stand at the center of reality to belong within it. A quirky tidbit often mentioned by astronomers is that if you could somehow leave Earth and watch the solar system's motion from an impossible outside perspective, the path might appear radically different depending on where you stood. Spiral, wave, loop, arc. The shape changes with the viewpoint. Reality remains the same. Perspective changes. There is a lesson hiding in that. Historians still argue whether humanity's greatest scientific revolutions emerged primarily from new discoveries or from new ways of looking at existing information. The answer is probably both. Observation and perspective often advance together. And tonight's journey has depended on both. You have followed measurements gathered by generations of astronomers. You have followed ideas refined over centuries. You have followed evidence, curiosity, mathematics, and imagination. Together they revealed a simple truth. The solar system moves, not randomly, not aimlessly, but as part of a vast gravitational choreography unfolding across cosmic time. A final gentle joke drifts by before settling into the darkness. Somewhere, the galaxy is carrying you at hundreds of kilometers per second, while your greatest current achievement may be successfully finding a comfortable sleeping position. Both journeys are valid. One is simply easier to measure, and now the pace begins to slow. The vast scales remain, the stars remain, the galaxy remains, but the urgency fades away. There is nothing you need to calculate, nothing you need to solve. The solar system has been making this journey for billions of years without requiring assistance. Tonight, it can continue without supervision. You can simply ride along. The darkness between stars no longer feels empty. It feels spacious. The motion no longer feels dizzying. It feels gentle. The spiral path no longer feels complicated. It feels natural. Like a river following its course. Like a leaf carried by a current. Like a melody unfolding note by note across an impossibly long song. And so, as your attention softens, you can imagine the Milky Way turning quietly around you, not rapidly, not dramatically, just steadily, patently, a galaxy keeping time on scales beyond human clocks. The sun follows its orbit. The planets follow theirs. The stars drift through their own trajectories. Every object participates in the larger pattern. Nothing is frozen. Nothing is isolated. Everything belongs to the dance. And perhaps that is enough. Perhaps it is enough to know that while your day may have felt busy or complicated, while your thoughts may have wandered through worries large and small, the universe itself continues operating with remarkable consistency. The same laws that guided the formation of stars guide them still. The same gravity that shapes galaxies shapes the path beneath your feet. The same motion carrying the solar system tonight carried it yesterday and will carry it tomorrow. You do not need to hold the universe together. You never did. The stars have their roots. The galaxy has its rhythm. The cosmos knows its way. All you need to do is rest. The immense spiral journey now begins to fade into the background. Imagine the Milky Way stretching across the darkness like a faint river of silver light, its countless stars glowing softly against a vast and peaceful sky. The solar system drifts within that river, not hurrying, not resisting, simply following the gentle contours carved by gravity over billions of years. Far below, Earth turns quietly. Oceans rise and fall. Clouds drift across sleeping continents. Cities glow briefly and then dim as night deepens. Above them all, the sun continues its silent orbit around the galactic center, carrying its planets through a cosmic landscape too large to fully grasp and yet somehow comforting to imagine. The distances no longer matter. The speeds no longer matter. The calculations can rest. You can let them go. The stars become soft points of light. The galaxy becomes a distant glow. The spiral becomes a calm, flowing motion that asks nothing from you. No decisions, no responsibilities, no effort, just movement, gentle and steady. You are part of that movement, part of that story, part of a journey that began long before your arrival and will continue long after. And that is perfectly okay. The universe does not require you to steer it. Tonight you can simply drift with it. Feel the quiet hum of existence. Feel the stillness hidden inside motion. Feel the comfort of knowing that even as everything moves, there is a deeper rhythm holding it all together. The solar system glides onward, the galaxy turns, the stars shine, and you can rest.